Hi and welcome to Train Signal. Failover clusters are characterized by a number of interesting settings that we need to discover, so we're going to explore them here in this lesson. In earlier lessons, we've noted the ability to configure a cluster to identify what its name will be for the purposes of those connecting to it. We've identified an IP address for it. You may have attended the lesson in which we explored quorum configuration behavior, but we've got a number of additional properties to explore beyond those basics. To fully flesh out our configuration of our failover cluster, we're going to need to support networking behaviors. A properly configured failover cluster is going to incorporate support both for client communication, but also behind the scenes communication amongst the servers that are participating in the cluster. So that will require a certain degree of network configuration. Plus, of course, we haven't discussed the issue of how to add services to actually run something on the cluster, and that'll require configuration. There may be circumstances where we want to add additional nodes to our cluster. Once we've got the cluster built, we may decide to scale up to a larger number of servers to be able to add additional quantities of redundancy, to be able to run a greater quantity of applications and services on that clustered set of servers. I may pause a server to be able to drain functionality off of it in preparation for a maintenance task of some sort. I may indeed evict nodes from my cluster that are no longer necessary in that organization. The applications that I put on my clusters will need to identify which servers they are most at home upon. Those are what are referred to as the preferred owners. And then we need to deal with the whole issue of how we handle a situation where an application fails on one server, fails over to another, and that application then needs to be restarted on the server from which it came, or perhaps not, depending upon our configuration. That'll all depend upon the configuration of a series of dependent resources, components which the failover cluster system manages independently, the failure of any one of which may well trigger the failover an entire role from one server to another. So let's jump over to the server environment and we'll see how that gets configured. In preparation for this lesson, I've gone ahead and installed the DHCP server service on servers 2 and 3. I've already done all my pre-work on server 3, but for your benefit, I'll complete the configuration of the DHCP server here on server 2. All that's really necessary in order to get the server software ready to be added, I'm going to cluster a DHCP server for the benefit of this lesson, is to finish the job of configuring the security groups and configuring authorization. We want to authorize a DHCP server so that it is usable on our Microsoft network. A couple of simple steps, and that's been done. The DHCP service is now ready to go. It doesn't have any scopes tied to it, but it is nonetheless ready to be configured somehow. So our goal is to do that by way of the failover cluster environment. So let me launch my failover cluster manager. And we can see that our failover cluster does include 2 nodes, servers 2 and 3, and at the moment it contains no roles. There's no software configured to run on top of the cluster. And of course our whole goal for having a failover cluster is to configure some piece of software to run on it. Those collections of features are referred to in the failover cluster configuration as roles. So I'm going to go right-click my roles node and identify that I want to configure a role. We'll then choose which one. And there's a list of a couple of dozen software capabilities that can be deployed on a failover cluster. Those components are cluster aware and are able to be managed through the failover cluster environment. For our purposes, we're going to use DHCP, but we could as easily deploy a file server or an iSCSI target server or other important components of our server environment. In this case, DHCP works well. I'm going to click Next. It wants a name for this clustered role, by which we mean that we want to be able to identify this service effectively as a computer in Active Directory again. Remember that when we created our cluster, we did so in such a way that it added an Active Directory user account. I'm going to try to keep the name within the 15-character NetBIOS limit, not because I have to necessarily, but it's kind of a nice thing to do. We need an IP address for this particular DHCP server. For our purposes, I'm going to choose the .240 address in my 172.18.38 network that I'm doing all of my client communication within. We obviously need an IP address that's in the IP address range of the other computers that are going to be participating in the network that this server is going to be part of. Beyond that, we would configure DHCP proxy servers and things of that sort. But that's a subject for the installation course, not so much a topic for our advanced services course. It wants to know which storage I want to assign to my DHCP server. Like configuring any other server, the software associated with this component needs to be stored somewhere. The DHCP database that's going to be managing our DHCP scopes and reservations and such needs to be stored somewhere. Storing it in shared storage is the logical choice for a failover cluster environment. We need that data to be somewhere where it's equally accessible by server 2 and server 3. So my iSCSI target is the logical place for that. The wizard is ready to begin doing installation, and I'm going to direct it to do exactly that. Now it claims here that high availability configuration is successful. That sounds great. I'm going to click Finish, and we're going to see a surprise. The failover cluster claims that this particular role has failed, that there's something wrong with it. Now, the interesting question is, what? One way to find out is to click to highlight that role, and down in the bottom portion of my window, we'll see information about what it is that's going wrong. And in this case, we can see that it has failed. We know the owner of the node is server 3. Okay. The node owner is server 3. The name of the DHCP server as it applies to our failover cluster environment. There's the name. That all looks good. Down below, I can click the Resources tab, and I can see that the complaint that it has is that it failed the process of establishing the name of the server. If I right-click it and try to bring it online, you saw the word processing scroll by there for a moment. No luck. If I right-click, sometimes you'll have the ability to get some informational details here, but in this case, nothing terribly valuable to us. So, what's happening in this case? One interesting feature of the failover cluster environment is that when it goes to create a new role, and I give that role a name and an IP address, that's very much like creating a new physical server in my environment. The failover cluster software wants to go update Active Directory and store information in it about this new server that it's making available. But it finds that it can't here. And the reason why is that I have not given the failover cluster the permission to do what it wants to do in Active Directory itself. So that requires a trip over to server 1. So here on server 1, let me jump to the Active Directory Users and Computers tool. The place that the failover cluster wants to create the new object that represents the DHCP failover cluster is actually in whatever container the failover cluster's own computer account resides within. In other words, because I see the Global Mantic's failover cluster object here in this server's container, it wants to create an object for the DHCP failover cluster in this same container, inside the same server's OU. Well, that's not a hard thing to do. I can right-click the server's container and configure the security settings under its properties, except for the fact that I haven't turned on advanced features yet. Now, I have no exact idea why Microsoft finds it necessary to hide the security features under the advanced features area, but they write the software, I just teach it, so I'm not going to complain too loudly. There we go. Security tab, in which I'm going to add support for the computer that represents my Global Mantic's failover cluster. And what I want to do is give it the ability to create computer objects in my domain. Those are child objects underneath the OU. I'll go ahead and grant read and write privileges as necessary. Having done that, let me jump back over to server 2, and let's try bringing the computer name resource online. So back here on server 2, I'm going to right-click the server name resource and bring it online. Ta-da! It worked. How about that? I fixed the problem with the DHCP failover cluster's name, and that triggered a refresh of the DHCP server service itself. That is online. I now have a working DHCP server running on top of my failover cluster. How do I configure it? Well, that's actually a simple process of right-clicking the role name itself and choosing to manage my DHCP server. And sure enough, there's a familiar-looking DHCP configuration interface available under the aegis of the Failover Cluster Manager. The Failover Cluster Manager has given me the availability of a standard DHCP configuration GUI within the confines of its own work. So I can use this to be able to create a new scope, for example. And I want to deploy the 170, let's call this the Failover Cluster Scope. What range of IP addresses do I want to hand out? Now I've already shut down the DHCP server on server 1 for demonstration purposes. 172.18.38. And let's give out IPs 150 through 180 using a Class C subnet mask, so 24 bits. No exclusions, no change to the standard 8-day lease duration, that'll be fine. Do I want to configure options? No, we'll configure those later. And we're good. I built a scope. I can right-click my scope and activate it. It is, for all intents and purposes, a DHCP server that happens to be able to store its information in a way that's equally accessible by two different servers. Now that I've done that, let's verify that I'm able to retrieve that IP address from a client machine. So here on the client computer, I'm going to go launch PowerShell, the one true command prompt environment of which all others are only mere shadows, in which I'm going to do an ipconfig/release to throw away whatever IP address might currently be on my network adapter cards. And let me go retrieve a new one. And we got 172.18.38.150. An interesting question is, where did we get it from? ipconfig/all will tell us that. And our DHCP server is 172.18.38.240. Well, what's that IP address? That's the IP address of the cluster. The cluster is responding to the DHCP request from the client machine. Practically, we know that at present, that role is being run under the control of server 3. But what happens if server 3 goes down? Will my client still be able to release and renew IP addresses equally well, even if the address is coming from a different physical server? Well, it certainly should. Let's verify that. So back here on server 2, I want to hand off control of the role from server 3 to server 2. A couple ways I can do that. There's a manual way to do it. If I know that I deliberately want to take server 3 offline for maintenance, I may want to deliberately stop that role, or to prepare to move that role to some other node in my failover cluster. I can choose the node of my choice. I've only got really one that I can move it to. Or I can let the software choose for me. If I say move to the best possible node, it will figure out what it thinks is the most logical choice in terms of how busy each of those servers are, and will trigger the transfer. You can see the software moving the resources over from one server to the other. It's now back up and running. It's now owned by server 2. Does the client experience a change? Let's go take a look on the client side. Here on the client, let me do another ipconfig/release. And we'll do another renew. And you'll note we get the same IP address again. Let me do an ipconfig/all, and it's coming from the same DHCP server, because as far as the client is concerned, this information is coming from the DHCP server. As far as the client is concerned, there is only one. You and I know that there's two of them, but we don't need to tell the client that. This is a redundant, reliable DHCP server configuration that ensures that no matter what happens to my server environment, if one fails, the other one is still able to continue handling IP address assignment for my client machines. Let's jump back to Server 2 and we'll illustrate some other important configuration options at our disposal. I demonstrated a manual transfer of a role from one server to another. But what happens if it happens accidentally? What if Server 2 is the owner of the role and suddenly one of its hard drives fails? What if, for some reason, its ability to register its name with Active Directory fails and that part of the system collapses? How do I then manage getting that role over to some other server? Now, I could wait to do it manually, but ideally we want that to happen on an automated basis. So even if the administrator is not nearby, this problem will handle itself. I'm going to right-click the role, pull up its properties, and we'll see that I have support here on the Failover tab for failover behavior. I can specify how many times within a given period of time this application is allowed to fail and keep getting failed over to other servers. At a certain point, I might decide it's not going to work no matter where I move it, and move it no more than a certain number of times within a given period of time. My other important consideration is, do I want to allow what's called failback? Failover is what happens when something breaks. Failback is something that I can allow when the server that had failed comes back into operation. Assuming that server is able to resume handling the responsibility of being the owner of some particular role, I can cause an immediate failback, or I can say we'll do failback but only between certain hours of the day. Maybe between 6 p.m. and midnight. And only during those hours will failback be allowed to occur. Perhaps that's a low cycle in the use of these servers. Another important configuration that I can perform is to adjust networking behavior. In many environments, you'll see that a failover cluster exhibits connections to 2 or 3 or more networks. In this case, I've got 2. I've got 2 cluster networks. One is using the 172.18.38 network. This is the one that my client computers are connected to. This is the one that the client got its DHCP IP address from. We used 172.18.38.150 for the client computer, coming from this range. That network is configured in a way that allows clients to connect through this network, which is what we saw, and importantly allows cluster network communication. Now what does that mean? That means communication between the servers, between the nodes that are part of the cluster. That might be used for heartbeat signals, as each server keeps each other apprised of their continued functioning. It might be passing of data as a virtual machine is replicated from one host to another. We'll talk about that a little bit later on. It is possible in certain circumstances to choose not to allow clients to communicate because this network is dedicated just to server-to-server internal communication. Or I could go the other way and not allow the cluster servers to talk on this network amongst one another at all. That's the scenario that I'll choose if I want to have a dedicated network connected to my failover clusters specifically for my storage environment. That might be for my fiber channel fabric, it might be for my iSCSI configured environment. Whatever my back-end storage might be, I may well want that dedicated on its own separate network, entirely separate from anything that the clients are saying to my servers, or indeed that the servers are saying to each other as part of their day-to-day work of keeping the cluster up and running. If the time comes that I need to add additional computers to my failover cluster, I can accomplish that from my nodes area. If I need to add a node, I can start the process of doing so, and it will perform the same operation that you saw if you watched my earlier lesson in installing a failover cluster. It asks for which server we want to add, and we'll begin the process of incorporating it into the cluster. In a similar way, I'm able to evict a node from a cluster if it no longer is going to participate in my environment. Evicting a node is saying, get out. I no longer want you to be part of this cluster. That server may well continue to have failover cluster software installed on it, but I'm not going to choose to use it, at least not part of this cluster. Perhaps that server will become part of some other cluster elsewhere in my environment. Another important configuration for our clustered roles is the management of what's referred to as preferred ownership. If I right-click my service, pull up its properties. I can identify here the preferred owners for this role. Among the servers that are part of my cluster, I can pick one or more that are the preferential locations for this service. And I can even rearrange them to choose which one of the two is the more preferred among my 2, or again, what might be as many as 64 different servers in this configuration. In this case, I would have chosen that I want server 3 to be preferred, and if I can't get server 3, I'll choose server 2 as my second choice. So you've seen the ability to deploy a clustered resource, in this case a DHCP server, on a failover cluster, be able to fail it over and fail it back from one server to another, and configure networking to be able to support all the various networking functionality associated with a failover cluster. Thanks for being part of the failover clusters lesson. Take a break, let your gray matter rest, and come on back in a while for another lesson.